Hi, welcome to the second lecture of the recursion series. And before we start, let us do a little recap of what we've done previously. Recursion is basically a process of solving a problem, repeating some task. Now, the original problem, let's say of size n, is broken down into smaller pieces at each step. And yes, not necessarily they have to be broken down into two pieces. It could be uh, n minus 1 as well. It doesn't matter. It's just saying that the problem is broken down into smaller pieces until we reach the base case. And base case basically means the smallest unit where these problems cannot be broken down further. And when we reach the base case, the real work is done. And then the solution of the base cases are sent to the previous level. This is known as backtracking. So eventually, the solution of every level will be sent to the level up and will be getting the final solution. This is what recursion is. In the previous lecture, we saw an example where my boss told me to buy him 6 ice creams, if you remember. So what I did was I broken down the problem into two smaller pieces, which is basically I asked two of my friends to buy me 3 ice creams each. So if these two of my friends buy me 3 ice creams, I can give all those 6 ice creams to my boss. So at this step, I'm waiting for the result of the following steps. These friends did the exact same thing. Friend one asked two of his friends to buy him 2 ice cream and 1 ice cream individually. And this friend did the same thing. This is basically repeating the same task. And at this level, when each person had 1 ice cream to buy, they couldn't ask anyone to buy them a half ice cream. So what they did was they actually bought the ice cream and gave them to the person who had asked them to do so. So when these two persons return 1 ice cream each, which is basically 2 ice creams, the task assigned to him is completed. So the task assigned to him was to buy 2 ice creams for this guy. And when these two guys return him 1 ice cream each, his work is done. And when his work is done, he will send the solution to its previous level or the friend who asked him to do that. And the same thing will be here done in this branch as well. So when these two persons get their job done, they will send the solution or send the result up. When these two persons have their jobs done, they will be sending the solutions to me. And I was basically waiting for the solutions from them. And when I get them, I send the final solution to my boss. So this is what basically recursion is. Now, using recursion, we can solve many problems. One of a very practical problem is uh, searching for an address. For example, this is where I'm standing and I'm looking for a house. And I have, let the circles be houses. And I have 3 roads, right? So I'm looking for a particular house. Let's say this one. And I don't know that this house is located over here. So what I do is I start I choose one, let me choose a different color. So I choose one path and search all the houses in this branch. And when I don't find them, I backtrack to where I was and start to do the same thing, which is basically search the house I'm looking for in a different branch. So over here, searching the house or searching the address is the task I'm repeating every branch. So this is a very practical example of recursion that we've done at some point of our lives, right? All right. So now we'll be starting today's lecture, and so we'll start by recalling functions. So we know what functions are and what they do, and we also know that functions can be of two types: void type, where we do not return any value, and we have a return type function where we return some value, right? So this is some function ABC, which simply prints a number, let's say 5, and that's it. Returns nothing. This is a void function. And let's say this is another function XYZ that returns the number 5. I bet all of you know the difference between print and return. That's very basic. Print is simply displaying the value 5, and return, sorry, it should be return. And return 5 means I am returning this value. We can say this is a physical thing, a physical a substance that can be used, right? This number 5, this value 5 can be used. For example, I can say print 5 plus xyz, like I'm basically calling this function. So when this function gets called, this value 5 is returned, and we can use this number with this number to get a result of 10, right? So this is basically the difference between a void function and a return type function. All right, so here's an example. Okay. So if you look at these two examples, you might be confused with one thing, that is this part. The funny thing is, if we go back, if we go back to the void function example that I wrote ABC, I simply printed a number and I didn't write anything over here, right? Because we didn't have to, because we are not returning anything. But over here, I mentioned the keyword return, but I haven't put anything over here. So this is a void function, and this is exactly this. Void functions can be said, or we can explain void functions as a return type function that returns nothing. Okay? Now, do not confuse nothing with none or null. Okay? Nothing and none, null are not the same thing. Returns nothing means nothing, blank. Therefore, if you look at this function m, I have printed hello, and at the end I have used the keyword return, and I haven't written anything over here. Now you might think this might cause an error or an exception, but interestingly, if you copy and run this code, this is a Python code. So if you copy and run this code, you see that this code works perfectly. So when we do not have to return anything, we do not need to write the word return. So this function is exactly print hello. So this is function M, print hello and writing nothing. So these two functions are exactly the same. Void functions do not return anything. So we do not have to write return. And we also can write return and keep this blank. Okay. This means that I am not returning anything. So this for a void function, the keyword return is optional. But for a return type function, we have to use the keyword return in order to send some value. Okay. So I have mentioned these in these points over here. So I've written void is also a return type function that doesn't return any value. Now, do not confuse with null none that I've mentioned before. And you don't need to use the uh, return keyword. It's completely optional. Okay, and for a return type function, you must use the word return. Now, more on return. So we basically know that the return word or keyword means that it carries a value, okay? But it does a little more than that. So if you look on the slide, I have written three functions and I've named them func1, func2, and func3. Okay. So function one basically prints a string first and then calls function two, and then there's another print after the function call. Function two prints second and then calls function three, then prints. There's a little typo over here. It should be X. So after the function call, there's a print statement which will be printing the value inside the variable X, and finally there will be another, and there will be a code over here. And finally, there will be another print statement with a string inside the parentheses. And finally, there's function 3, which prints the string last and returns a string red. So if I call function 1, execution will start from here. And let's trace the output. So the execution will start from the first line. Then I first get the print statement and my output is first. Then there's a function call. So before I move to this line, there's a function call. So I move from this line. So let me use another color. So from this line, I move into this line, right? Now function 2 is running. It prints a statement or it prints a string second. And then calls function 3. So before these lines get executed, let's call it an execution pointer. My execution pointer will be pointing to function 3. And then function 3 will start running. First, it will print the statement last. And then it will return the value ret or the string ret. Now we know that when we return a value, this return will be this value will be returned and stored inside the variable x. So when a function ends, it goes back to where it was called the first time. So function 3 was called over here. So when the function 3 ends, it goes back to goes back to where it was called in this line. And as it's a return type function, it will carry along this string and store it inside the variable x. So the variable x now contains the value ret. So after this line gets complete, after this line is complete, or after this function call is complete, my point execution pointer moves to this line and it prints the variable x, which means ret will be printed. And then there's another print statement which prints a string called second last. And as I move down, this is the end of the function call. And we know from the previous slides that every void function is also a return type function, but not returning anything. So when I move to the end of the function call, there is an invisible return line which will help us to go back to where it was originally called. So the word return does not only carry a value, but it also returns the execution pointer to the place where it was called the first time. You understand? So these are by execution pointer, I mean uh, the, uh, the current line being executed. So when the pointer moves down, executing one line after another, when it reaches the end, it will find an invisible return statement without without a value beside it. So it means that my pointer will go back to the place where function 2 was called, and while going, it will not carry any value along with it. So my execution pointer is over here and function 2 is done. Then my pointer moves to the last line and it sees it's printing, it's a string, it prints a string called last. And again, the pointer moves down and it finds the end of the function. The end of the function is basically an invisible return word without any value. So it goes back to the place where it was called the first time. So when it comes back to this statement where function was called the first time, the entire function call or the entire execution is completed. Okay. So the word return means return to the place where the function was called, right? Or return means return the execution pointer to the place where that particular function was called. And while returning, you might return a value if the function was a return type function, and you might not return a value if it's a void function. All right, I hope you understood. Now there's a question. Now, how does a program pointer know exactly where to return? So when the pointer sees the word return, it knows that I must return to the place where I started. But where did I start? So what I mean is, for example, from here, when my when a piece of code saw the first return, there were two function calls if you remember. The first function call was inside function 1, and the second function call was inside function 2. Now, when in this line, when the execution pointer sees the word return, should it return to function 3 or should it return over here? Now, there are two places, right? But interestingly, from this, the The pointer, when this function tree is completed, the pointer does not go to this place. The pointer goes to this place. And how does the pointer know that it is this is the correct place? And the answer is a stack. It uses a stack. Okay. So before we move how stack is working over here, I think we should call it a day. And this is the end of lecture 2. So in the third lecture, we will be discussing where does the stack fit in. Okay. Thank you very much.